So yesterday we concluded the definition of science with different examples and the retrospective extraordinary work done by Indian sages. They were called as sages, but they are far more better than the Western scientists. So I just try to link the extraordinary contribution of our Indian sages in the field of science, mathematics, medicine, etc. That's where we concluded. So I referred about the science definition as the describing, creating, and understanding facts of the human experience. I also told you the perception will be different for different human beings, and based on the perception, yes, we will get a beautiful scientific research aspect, we will get a mathematical theorem, we will feel physical experience. Suppose if the sunlight falls on our body, ఎండ మన ఒంటి మీద పడగానే చురు 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 అనే ఫీలింగ్ వస్తుంది. దీన్ని మనం ఫిజికల్ ఎక్స్పీరియన్స్ గా చెప్తాం. సైకలాజికల్, సోక్రటీస్ ఎక్స్పీరియన్స్ చెప్పా మీకు. So that's called psychological. Physiological means something related to health. Mathematical, scientific, these two we discussed. Medical perception means, yes, suppose if you look at any plant, if you look at any flower, say nowadays Anandaya has become so popular near Nellore. He is giving beautiful medicine for the recovery of corona patients. All components, ingredients in his medicine were from the nature only. So how could he do that? He started, his ancestors in fact started making trial and error about the medicinal values of various plants and nuts, etc. around them, and finally he could club all these components and make a medicine. Successfully he is giving for thousands of patients, corona patients, who are recovering instantaneously. So that's called medicinal perception. So whenever you look at the nature, whenever you look at some plant, whenever you look at some flower, whenever you look at some nut, your mind, if you have a medical perception, your mind will be thinking about the medicinal values of them. So this is what I mean by perception of mind. So based on the human experience, the mind perceives the things and reciprocates according to the taste of the mind. It may be physical, it may be physiological, psychological, mathematical, scientific, medicinal. So now, how a scientific concept or principle will evolve? For this, we have steps. We call it as scientific steps. So first one is the definition of science. Now we are moving to the second topic called scientific steps. So there are 5 steps involved in sequential steps followed for evolving a scientific principle or formula. First and foremost one, observation. Observation with scientific perception. Second one is hypothesis. Third one is experimentation. Fourth one is data collection, graphs, calculations. And the fifth one is inference or conclusion. So repeat once again. The sequential steps followed in evolving a scientific principle or formula or theory or derivation are 5. First and foremost one, observation with scientific perception, because different perceptions cannot give you, if you have a poetic perception, that won't come out in the form of a scientific formula. Therefore, observation with scientific perception, hypothesis, experimentation, data collection, graphs, calculations, inference or conclusion. First one already I explained you yesterday. Immediately after getting up from your bed, if you come out of your house into your garden around your house, and you observed small tiny droplets on the petals of the flowers or the leaves of the plants in your garden, and you observed the sunlight, the lukewarm rays of sunlight falling on the water droplets, and after the incident on the water drop, it will be dispersed, it will be splitting into the 7 colors. This phenomenon, we name it as dispersion. So this is called the observation. Hypothesis means you get something. Yes, any refracting medium can split the polychromatic light into different colors. This is hypothesis. Next, experimentation. You take a small glass sphere, you take a small glass prism, you try with soap bubble, you try with water droplets. This all comes under experimentation. You try with sunlight, you try with light from mercury vapor lamp, you try with tungsten filament lamp, like that. This is all called experimentation. And in the experimentation, you will be getting some data, useful data. We list out all the data. Nowadays, the computer is automatically recording. When I was doing my research in space physics in Andhra University, Voltaire, in 1986, we used to do everything manual. Even the setting up of apparatus also, we used to do manually. So we used to struggle a lot while doing research. But now things have become so easier. The simultaneous experimentation will be recording the entire data. Research has become more easier nowadays than those days. So using the data, we'll get some variables. Using those variables, we'll try to establish the relations, directly proportional, inversely proportional, like that. They are called relations. And from that, we'll be drawing the graphs. Then we'll do the calculations. After all that, we'll now get the conclusion or inference. What is that? A polychromatic light, when it is made to pass through a refracting medium like glass, prism, or sphere, soap bubble, or water droplet, it splits into 7 colors. So it is called as dispersion. Similarly, another example which we quoted earlier, in fact, a lot of research was done by Sir Isaac Newton on this dispersion. Newton's disk, I think many of you might have seen in your high school. మామూలుగా చిన్న డిస్క్ ఉంటుంది, దాని మీద 7 రంగులు ఉంటాయి, చిన్న హ్యాండిల్ ఉంటుంది, తిప్పుతూ ఉంటే అది అలా తిరుగుతూ ఉంటుంది ఆ డిస్క్. నాకు 7th క్లాస్లో మా సైన్స్ మాస్టర్ చూపించారు. తిప్పుతూ ఉంటే స్లోగా తిప్పుతూ ఉంటే రంగులు గ్రాడ్యువల్గా డిసపియర్ అవుతూ ఉంటాయి. బాగా స్పీడ్గా తిప్పేస్తే the disk entirely appears white, even though there are 7 colors. When you start rotating the disk at one point of time, slowly the different colors will start disappearing, and at one point of time, the entire disk will appear as white. This was called Newton's disk. So similarly, Newton observed the falling apple, that is observation. He got some question why the apple is falling towards the ground, why it is not rising up. Then he got an idea, there is some force which is pulling all the objects towards the Earth's surface. Then he conducted experiments taking various objects. Even Galileo conducted experiments on the Leaning Tower of Pisa. I will show you in laws of motion. All those PPDs I will show you in the laws of motion. So I don't want to do entire physics in the introductory classes. So he conducted experiments with the support of Galileo's observations, and finally he collected all the data. A feather, when it is allowed to fall, how it is moving, how much time it is taking, what happens if it is made vacuum, what happens if air is there. Then he dropped a pebble, he dropped a coin, he dropped a marble, he dropped a big stone. Like that, different objects were allowed to fall in air as well as in vacuum, and he collected huge data, substantial data. Then he plotted graphs between time taken, distance covered, next time taken, velocity acquired, time taken, acceleration produced, all these things he got graphs, then he made calculations. Finally, he concluded that yes, Earth has got the gravitational force under the influence of which every object will fall towards its surface. Simple example. Similarly, Stevenson noticed the dancing lid over the vessel. Observation. Hypothesis. He got an idea. Yeah, steam can may do some work. That's called hypothesis. Experimentation. Yes, he took vessels made up of different metals: brass, copper, silver, iron, aluminium, etc., with pistons. Then he kept them in vacuum. Then he kept them in air. He kept them in insulated wooden boxes. Next, he put the steam, subjected the steam, allowed the steam into this cylinder. Then, after all experimentation, finally he got the parameters like pressure of the gas, volume of the gas, work done by the gas, all those things. He plotted graphs. Then finally he understood that steam, when compressed, can do some mechanical work. Please don't do anything on the screens, okay? Yeah, just hear quietly. Try to note down what I'm telling. I will tell you now. So thus, the final inference or conclusion out of Stephenson's experiments were steam, when compressed under high pressure, will get the capacity to do the work. So these are all, this is how, whatever Stevenson's experiments, then Wright brothers experiments, prior to them, Talapade and Subramanian, they kept the mercury vapor under high pressure and they could drive the aeroplane by applying the condition of buoyancy. So thus, any scientific principle or concept will evolve only through these five steps. But the basic thing is one should have the scientific perception. You cannot keep P.B. Shelley and ask him to discover something. You cannot keep our Indian poets Kalidasa, etc., to write one scientific principle. Impossible. So that's all. Socrates is not a good scientific inventor, but he's a great philosopher. Like that, the perception of the mind should be scientific. Then the first and foremost step is observation with scientific perception. Second one, hypothesis means guessing something without experimental support. Third, experimentation. Fourth, data collection, graphs and calculations. Fifth, inference or conclusion. Please note down them. Please note down. The sequential steps. The sequential steps to be followed. The sequential steps to be followed in evolving. The sequential steps to be followed in evolving the scientific principle or concept. The sequential steps to be followed in evolving the scientific principle or concept are called the scientific steps are called the scientific steps. They are, are you writing? Someone should tell me. Raviteja, you should tell me whether you are writing or not.
Yes, sir.
Okay. Yeah, if you write, your mind will memorize them. Just hearing will not memorize. It will be just like a movie, observed and came out, and after some time you forget everything. No, you should write. At least whenever I say you write, you please start writing. Are called scientific steps. So number one, observation with scientific perception and temperament. That's also very important. You may have perception, but you are not tempered. Means you don't have that zeal or energy to explore. And the temperament. Second one, Second one, hypothesis. Second one is hypothesis. Put two dots and write against that. Guessing out of observation. Guessing out of observation. Without certainty. Guessing out of observation without certainty. Third, this is there in your plus 2 syllabus, introduction, first lesson. NCERT I am talking. I don't know what you have in your intermediate board syllabus. It is there, I'm sure, because both the state governments are following NCERT only, I remember. So third one is experimentation. Put two dots. Helps in confirming the authenticity. AUTHTICITY. Helps in confirming the authenticity of the hypothesis. Helps in confirming the authenticity of the hypothesis. Fourth one, data collection, comma, graphs between different variables. Graphs between different variables with calculations which yield which gives yield means give, which yield all possible relations among the variables obtained, which yield all possible relations among the variables obtained. Fifth one, inference or conclusion. Inference or conclusion. The careful analysis with the accurate results obtained, will either support the hypothesis or disapproves it. Note, if the inference supports the hypothesis, then it becomes a scientific principle. So I need not tell other thing, otherwise it is no. Correct?
Yes, sir.
We have many such examples in the scientific research. Newton. Let us take the familiar example, Newton. He thought light is in the form of rays. Can I clear this screen?
Yes, sir.
Okay.
Yes, sir.
Yeah, anything? Yes?
Nothing, sir.
Okay, okay. So, Newton, while he was the first man to talk about the nature of light, so he said light will be in the form of rays and light is in the form of particles,
Wave.
and light needs a medium for propagation. Another scientist, Huygens, he said light will be in the form of waves and medium is needed. Whereas Maxwell, he said light is electromagnetic and no medium is needed.
Who is right, sir?
Light doesn't require any medium. Just example, how the light from sun is reaching us. Light, heat, both. We have atmosphere up to maximum 5 to 600 kilometers. Up to the beyond that also atmosphere is there, but very thin, very thin. So complete vacuum is there between sun and earth, but still the light rays are propagating, heat rays are propagating. We have 100 billion stars, means 10 to the power of 11 stars are there in the entire universe. In the night, if you just go onto the terrace and look into the sky, you will see thousands and thousands of stars. If you have a patience, start looking in the horizon from east to west, then from north to south, then from northeast to southwest, like that. So look in all the 8 directions. You will see thousands of stars twinkling in the sky. So the light from those stars, we are able to receive them. Means no medium is there, nothing is there present. Even then, the light rays are moving through vacuum. Hence, Maxwell's attributed the electromagnetic nature to light. So whatever Newton said could explain only 2 phenomena. Well, they are reflection, refraction. Huygens, he explained all the phenomena, reflection. Yeah, it will be ending in 10 minutes. So don't skip off. Every day you are skipping off. I'll be relogging immediately. So wait for me. Just 2-3 minutes pause will be there. I'm informing you in advance. So he explained reflection, refraction, interference, diffraction. There is one more phenomenon he failed to explain. And the polarization, the leftover phenomenon, polarization was explained by Maxwell. Another example is, initially people thought Earth was flat, but by observing the chimney of the ship coming in the oceans, they said Earth is not spherical, sorry, Earth is not flat, it is spherical. Like that, many theories, geocentric theory was proposed by Indian astronomers. Finally, Bhaskaracharya said it's not geocentric, it is heliocentric. All the planets are moving around sun in the elliptical orbits. He even gave the formula, mathematical formula for the eccentricity of the orbits. Even in Western astronomers, Ptolemy, he suggested geocentric theory. Copernicus suggested heliocentric theory. He said orbits of the planets are circular. Finally, Kepler confirmed that orbits are not circular, orbits are elliptical. They started talking about the planetary motion in the 2nd century, Ptolemy. Don't call Tommy. His soul will be weeping. So Ptolemy. And in 15th century, finally Kepler confirmed that the orbits of the planets are elliptical. This was told by our Indian astronomers Bhaskaracharya in the 6th or 7th century, well before Kepler confirmed that orbits of the planets are elliptical, and he even gave the mathematical formula of eccentricity. He was one of the greatest mathematicians of the world, plus astrophysicist. Like this, many theories were suggested in the beginning. Later, after experimentation or careful analysis, they confirmed that the earlier theories were to be modified or earlier theories were totally wrong and a new theory is to be introduced. This is what I mean by the inference or conclusion. If it supports, it evolves in the form of a scientific principle. If it disapproves, then what all work done by those scientists will go waste. So this is about the different scientific steps. Then, shall I remove it? Shall I remove the screen?
Okay, sir. No.
I am clearing the whiteboard.
Okay, sir.
Okay,
Continue.
fine. You say, sir, you're telling as if you're talking to a friend? Huh?
Yes, sir.
A person with 36 years of experience with international exposure is teaching you. We should have some formalities, man. Okay. Yeah, nice. Don't feel bad. The teacher has
Okay.
to correct the students. Parents and teachers only have got the right to mind the students and correct the students. And I just cannot keep my class going on without following formalities from my side or from your side. Then, next one is the philosophy. What philosophy should be there for a person to become scientist? This is very beautifully presented by one good educator. It's called B2U. B means basics. U means unlimited. This number 2 means 2. TO2. This is called philosophy. Philosophy of learning science. Basic to unlimited means you should feel that you do not have any content in your mind when you start learning, and you should never feel that you learned everything. I think you are very clear. నాకు కొంచెం వచ్చు అనుకోవడం తప్పు, అలాగే నాకు సర్వం వచ్చు అనుకోవడం కూడా తప్పు. అంటే నాకు అన్నీ వచ్చు అనుకోవడం కూడా తప్పే. నాకు ఏమీ రాదు అనుకుని మనం లెర్నింగ్ మొదలు పెట్టాలి. నేను నేర్చుకోవాల్సింది చాలా ఉంది అనుకుంటూ జీవితంలో ఎదగాలి. Even when you are a student, there are a lot more things to learn. Even if you enter the profession, there are a lot more things to learn. My son did his BTech, he did his MTech in Andhra University, he did his MS in Sweden, but now also he is learning some courses to continue his profession. So learning has no boundaries, learning has no limits, so it is unlimited. Even a teacher must be keeping on updating himself. I was not knowing to use these gadgets till 2019, but Corona made me to learn it. I learned from my son. Yeah, that's fact. I learned from my son. I learned from my daughter. I learned from my daughter-in-law, who helped us in using these gadgets, who helped in using the software, who helped in editing the things, who helped in giving a Google link. All those things I was not knowing. I learned from my children. Yes, that's why even many more things are to be learned by me. Hence it is said unlimited, basic to unlimited. This should be the philosophy. I would like to tell small experience of small reference of Sir Isaac Newton here. Isaac Newton was the president of Royal Society of England. Nowadays, we are not seeing. Earlier, we were seeing FRCP, FRCS. Yeah, those doctors were having a lot of popularity. FRCP, Fellow of Royal College of Physicians, Fellow of Royal College of Surgeons, Fellow of Royal College of Physicists, Fellow of Royal College of Mathematicians. So if anybody has this FRCP degree, then he was considered as the topmost person in the society. To that society, Newton was president. He was highly egoistic. No one was there to stand before him. No one was there to talk to him. Everybody was shivering before they enter into his chamber. Such a man, because he spoke about every branch in physics, mechanics, laws of motion and all, heat, Newton's law of cooling, optics. He explained the nature of light. First man to explain the nature of light. Theory of relativity. He was the first man to introduce. Mathematics, calculus. He was the man who framed it. Such a great man, you know, after he retired, after he stopped, he became so old, his intellectual caliber has gone down, and to relax, he went near to the ocean. A small shell came into his hands. He picked it in his hands, and it became so hot. మామూలుగా ఈ నత్త సముద్రంలో వచ్చే నత్త ఏమవుతుంది, లోపల ఉన్నప్పుడు క్రీచర్ బయటకు వస్తుంది, దాని చేతిలోకి తీసుకుని బయటకు తీసేస్తే గట్టిగా రాయి కన్నా గట్టిగా అయిపోతుంది. ఈ న్యూటన్ ఏం చేస్తున్నాడు, దగ్గరకు వచ్చే కాళ్ళ దగ్గరకు వచ్చే సముద్రపు నీళ్ళని తీసుకుని దాన్ని స్ప్రింకిల్ చేస్తే మళ్ళీ అలా ఓపెన్ అవుతుంది అది. సో ద షెల్ is becoming so hot when a few drops of water were sprinkled on it. Again, it's getting opened. Then he said, what all work I did is nothing before the unlimited ocean depth of science. So he admitted his innocence before the secrets of the nature. Just stay back. I will come back to you just in few minutes. I will resume the session. Don't go away.
Okay, sir.